Hello, welcome to the second video in Basic Statistics. In this one we will be checking the data that you have already loaded into SPSS for errors. You will need the file that you saved at the end of the last session called lap_hernia.sps, and that should be on your University of Edinburgh account drive. You will also need SPSS 19, the software. We will be checking the integrity of the data, finding some errors and fixing those using Recode, and this is an essential part of preparation of data before you can go on and do any analysis. So if you bring up SPSS, you should have this opening screen, and for me the second line mvm.ed.ac.uk is my previous file. So if I double click on that, then I get where I left off last time. So the first thing to do is to check the data, and we're going to use that. We're going to do that using the frequency function. So if you go to Analyze, Descriptive Statistics, Frequencies. So it's the first in the list of descriptive statistics, and if you click on that, if you hold down the Shift key and click on Pain Score, then that will highlight all the variables and then scoot them across to the variables box using this button in the middle here. Ensure that Display Frequency Tables is highlighted. Then go to Statistics and click Quartiles, Mean and Range, and click Continue, and then go to Charts and ensure that none is clicked on Charts for the moment, and click OK. You'll now see the output from SPSS. This is the instructions in code that you've put in, and the first box here in the front is called Frequencies Statistics. Here you have columns which represent each of your variables: patient ID, age, gender, recurrent, laparoscopic and pain score. It tells you the number of valid pieces of information in each of those variables, and thankfully in this data set it says 50, which is the number of patients we have, and no missing. So this is unusual. There is no missing data in this in this data set. In the next video we're going to look at the basic summary of continuous and factor variables using these figures down here, so we'll come back to this in the next video. Next is the frequency tables for each of the variables. So patient ID, for instance, has each of the levels within patient ID: 1, 2, 3, 4, 5, 6. So here we want to check that the frequency of each of these is only 1. If, for instance, in 7 here there were 2 patients called 7, then we would know there was an error there in that 2 patients had the same patient ID. So by scanning down that list, we can see that each patient ID only has 1 row, and that is as we would expect. Ages, well, more than one patient can have the same age, so that is not the case for that. We'll skip past this. Gender, now there's a problem here. In gender we have F, fem, female, M with a missing space, ale, male. So we have a number of different identifiers for female and a number of different identifiers for male. So this means, as it stands, we cannot use this variable at the moment for analysis. Now, obviously in the Excel spreadsheet or on the data view in SPSS yourself, you could just go and change these by hand. But if you have a table which is 60,000 rows long, then it's not going to be possible to do that. So this is essential for dealing with data which is in any way larger than the data set we have at the moment. Continuing down, we see recurrent, which has just no and yes and the frequencies and proportions, and laparoscopic just says no and yes with the frequencies and proportions, so they're okay, and we don't need to worry about pain score at the moment. So it looks like we've got some work to do in gender before we can use this data set. So what I want to do is recode gender. So I've got the output window up here, and the menu, note that the menu bar is the same in the output menu as it is in the data view menu, which is handy. So I'm going to go to transform, and there's two recode options. You can recode into the same variable, which means you're actively changing the variable which is there already, which I wouldn't suggest you do. I would suggest that you make a new variable so that it's exactly clear what is old and what is new. So recode into different variable, and this brings up this box. So it's gender that you want to recode, so scoot that across, and this is now saying gender is being recoded into something, so you need a new variable name. So I'm going to call that gender underscore new, and click change. So this is my old variable and my new variable, and then I'm going to click old and new values in order to recode. Now, similar to our other factor variables, I'm going to recode gender as 1 for male, the numeral 1, and 2 for female. So I'm going to put in the old value F, new value 2 for female, and add. Then fem 2, add, and then complete all the other ones, fem, female, m, male, male, and click continue. Takes you back to the recode screen and click OK. Now go to the bottom of the output screen and check that the command is executed with no errors, which it has. Go to the variable view screen and check that there's the new variable there. There we are, gender new. It's nominal. Decimal places comes up as 2 by default. You can put that to 0. And then similarly in the values, we can click 1, male, add 2, female, add, OK. Let's check that it's worked. Go to Analyze, Descriptive Statistics and Frequencies as before, but this time scoot all the variables you've looked at back over to the other side, but using Control to select both gender and gender new, scoot them across and push OK. So here's gender and gender new with the 5 number summary that we'll look at later. And then here's our old table. Now I just wanted to bring this up again because I didn't highlight that in this table there was one of the rows that didn't have any identifier at all. Now this didn't come up as missing because it didn't have, it was a space in here rather than it actually being recognised as missing. But in our recode, it has been identified as missing because we haven't given that variable an identification. We haven't said it to be either 1 or 2. So in fact, in gender, there is one missing row. We do not know the gender of one of the patients, and you can go back and check on the Excel sheet that that is indeed the case. And we can see in gender new now that we have 26 males, 23 females, so we have 49 in total for gender. So the last thing we want to do is to save the data, so go back to the data editor, file, and click save. You can check that that's worked by going to output, looking at the bottom, and ensuring that it is saved without any errors, which it has. You can also, if you wish, save these output files by going to File, Save As, and you can see the output is saved as a .spv file. So we could call that lap_hernia spv, and that will save all the information that we've taken in the output. Okay, that's it for this one. In the next one, we'll describe the data and begin analysing it.